Assalamu alaikum everybody, this is me Khalil Houthi. Here I would like to show you how you can install Refract software for seismic refraction data analysis. These are the documents I already sent to you. They are available in Moodle. The most important are first of all the data as well as the software, Refract. So let me first unrar or unzip. I click on this one, Refract. Let me extract all in the same folder. Extract. Done. So I do have right now another folder, unrarred folder, normal folder. Let's go inside again. You have two different things. One of them is a file, the application file. Basically, this is the one you use to install the software. The other one is to apply what we call medicine. Let's first of all install the software. I just right click and choose run as administrator. I click on yes. So I get a wizard. I go choose next. Uh, I keep track of where the software is installed. Right now it's getting installed in this folder. C program files 86 and iExtraFrax. So let's choose the default and click next, next, next. So basically during the installation, you change nothing. You just go through the default choices available during the installation. Next, I go to crack folder. I go to crack folder, choose everything, Control A, Control C, copy them, copy all the selected files, then go again to C. Let's see where is program files 86. Here is it, program files 86. And let's search for Refract. That's the one. And I paste actually the files I copied from the crack folder here. So click Control in the keyboard, Control C or Control V. And let's do the same for the remaining. Continue. Yep. So I can right now open the file, the application. Let me also unrar the data file. Basically do the same for data file. Extract them in the same folder. Here they are right now. Let me open the software. I just search IX Refract. This is what I get. This is what I get. The first thing is to import the data. So let's click on this icon, create new spread, and from here choose the default. The data format is SIG2. So next, we need to search in Lab4 data again and select all. So this is what I get. Let's modify the y-axis range, make it from -5 to 125, 120 probably. Let's see. What I can do, I right click here, right click somewhere here, and this will pop up. So in the station, I start from -5. Let's apply. Good, that's good. So starting from -5 to 120. That's good. Next step is start picking. We go shot by shot. This is the first shot. You just need to hover on any of these curves. Once the curve turns to green, right click on it and choose display traces. So how you start picking, you hover with your mouse. Once you highlight any green curve, go right click and choose display traces. And this is the window you get. So we are actually interested on the shallow part. And you can zoom using this icon, this option in here, toggle zoom state. And within the boundary of the axis inside, draw a rectangle. Draw a rectangle just covering the shallowest part, something like that. And it's good to display the travel time curves, our pickings on the next shots. So the pick I make on this shot, shot number one, I would like them to be displayed or shown on the next shot. And this can be done if I activate this icon, toggle display of travel time curves from other shots. So let's start modifying. You see there is the initial picking as I described have been made by the software itself. Shot number, there are five shots. Shot number one and five are the noisiest. The reason being they are farther away. The last Jufun actually is farther away from the source location. The source is located 3 or 1 meter away from the first Jufun for shot number one. And that's it. We can modify it. We go back and forth if there is any mistakes we have done during the picking. So let's go to the next. You see the black line. This is the picking from the previous shots. So it seems that we need to lower it down. This is what I believe. We need to, previous one, we need to modify it. Shot number one needs some modifications. Let me go back to previous shots and slightly lower it down. You see, this is the previous shot, shot number two. It should be shallower than shot number one. Let's go here. I think this is good. And this is number three, which is actually the cleanest. It has the highest signal to noise ratio. Let's go to the fourth one. So the fourth one is between Jufun 18 and 19, and we have total of 24 Jufuns. And finally, the last one. I think this is nice. You can keep pressing on U in the keyboard to increase the amplitudes, or D to decrease the amplitude. This is just for viewing purposes. So I believe this is done. Click OK. Let's refresh this one. I just drag it. Yeah, that's perfect. This is very nice. This is interesting. So let's do one thing. Let's build a model, and we need to provide an estimate, an initial model, and the software itself will start updating it. The way we can do it, the simplest way in here is to right click, choose any curve, one side of the curve, right click and pick the first option, flat refraction interpretation. That's what you get. So it displays an initial possible model. It says that there are two layers. The velocity of the first layer is 500. The velocity of the second layer is 2000. And the thickness of the first layer is 5.2 meters based on this TX diagram. I choose another one. So here is 600, 300, 3500, 9.5. And you can choose something in between. So this is 500, 7.9, 3000. Let's choose this one, see what it gives us. This is a bit high. Choose this one. This is a bit low. So I believe an initial model having two layers, and the velocity of the first layer is around 500. Velocity of the second layer is around, let's assume 2700 is sufficient or good. So surface layer velocity, let's make it 5, and velocity of the second layer 2700, and the thickness, let's make it 8 meters, and click OK. Increase the number of iterations, let's make them 20, and choose the default minimum errors, 0.9 and 1 millisecond. Let's run it again. Inversion parameters, yeah, 5 is enough. So here is it. Um, the RMS error is actually very good. So I'm getting 5,000, 511 velocity as initial velocity, and the second layer velocity is 2,700 almost. And it's varying in terms of thickness from one place to another place. So if you go back to the answers you need to solve, so the first one, it says take a screenshot of the model you created and display it here. Another thing you can do also, instead of just two layers, try to make three layers. يعني choose this one, flat, increase the number of layers, make them three, and try to guess some or estimate some initial velocities. So it says the first layer is 500, the second layer is 1000, whereas the third layer is 3700. And these are the thicknesses of the first and the second layers. So you try this one, see what difference you get between only having two layers or three layers. The remaining you can actually solve them yourself. What's the RMS error for both cases? And what is RMS for both cases? They mean the case for two layer or three layers. What's the theoretical and calculated observed arrival times? What they represents? What's the average depth of the second layer? And also the thickness of the third layer. If I make an update here, and you need to solve based on the updated document. And what's the maximum depth of investigation? And what we can do to increase it? So you need to solve these questions and post the answers to Module. I make a new link for you to upload the answers. Great. So I'm stopping recording and hopefully you will have no issue with the lab. In case you have technical problem installing the software, I'm available in office to help you.